Obtaining environmental information will be common logic that is performed within your OPSINFO rules and programs. Information such as the SMF ID or sysname of the system, to the date and time of the most recent IPL. The OPSINFO OPSREX function will be one tool that can be utilized to obtain such information. Data such as OPSINVS related information, detailed information on the currently executing ACID that triggered the automation, as well as different forms of system-related data, such as the CPU information and IPL and Sysplex related information. This function is available in both OPSINVS rules and OPSREX functions. A user-defined simple variable name, or var name, is commonly coded to invoke the OPSINFO function. The name of this variable should reflect the type of data that is to be obtained and returned by the function. For example, if the OPSINFO function is being used to obtain the current status of OMVS, a variable name such as OMVS_status would logically define this data. In this example, the OMVS_status variable would have the possible values of ready or not ready based on the current state of OMVS at the time the function is executed. The string text that is specified within the OPSINFO function identifies the specific environmental information that is to be returned. Using this previous example, OMVS is the string text argument of this OPSINFO function call. Currently, there are approximately 100 OPSINFO requests that can be invoked. A complete list of these available requests can be found in the documentation link mentioned at the end of this video. Let's now take a quick look at some commonly used OPSINFO functions that can be utilized within effective automation. Here are some commonly used OPSINFO function calls used to interrogate the OPSINVS environment. A string text that subsys to the function would return the subsystem name of the currently running OPSINVS region. The status of the System State Manager component, or SSM, can be obtained via the stateManStatus string. The main_parm argument can be invoked to determine what value was used to start the OPSINVS region. This function is commonly used to perform different automated actions based on an event or a particular system at the time OPSINVS is initializing. The product starts and product status OPSINFO functions can be used together to determine if OPSINVS is initializing for the first time after an IPL. Upcoming coding samples within this video will provide more usage details on these functions. Depending on the specific automation request, you may have the need to obtain additional environmental information regarding the address space that triggered the automation, such as an OPSREX program that is running in batch or in the foreground of a TSO user. Various flavors of the OPSINFO function can obtain data such as the account number, address space ID, job name, job ID, and step name of the current address space. The OPSINFO program function can be used if the name of the currently running program is needed within the automated logic. This may be useful in creating OPSLOG audit trail messages indicating the action taken by a particular OPSREX application. From the detailed list of available OPSINFO functions that you will find in the commanded functions documentation, you'll see a slew of system-related requests. Common OPSINFO function requests such as SMF ID and sysname can be invoked to obtain the current SMF ID or system name values in which the automation is executing. Many other system-related information requests can be invoked, including calls to interrogate the CPU configuration to information about the recent IPL. All can be obtained via the OPSINFO function. Now let's take a look at a few coding examples taken from some OPSINVS automated applications. This particular code is utilizing the OPSINFO main_parm function to determine the value of the main_parm parameter that can be optionally set on the ZOS start command that is used to initialize OPSINVS. This is one effective method of performing logic in your automation based on some environmental condition that is derived prior to the starting of OPSINVS. In this particular code, the System State Manager or SSM component of OPSINVS, which automates system STCs, is being instructed to only start core or system critical resources if the start command of OPSINVS included a main_parm equals core STC statement. This is a typical system request during a maintenance window that is performed after an IPL, or perhaps in an emergency IPL situation where you do not want to initially start up all system resources. This particular code is utilizing the OPSINFO function to obtain various types of environmental information. The automated outcome of the code will log an informational message to the syslog and opslog with this information. Note the OPSINFO product status, which returns a value indicating if OPSMVS is initializing, fully active, or terminating, and the OPSINFO product starts, which indicates the number of times OPSMVS has been started on this system at the beginning of the code. Together, these OPSINFO functions can be effectively used in the init section of any AOF rule when you need to determine if OPSMVS has just been started for the first time after an IPL, thus allowing you to create if-then-else logic based on OPSMVS starting for the first time after an IPL. The subsequent OPSINFO functions are obtaining information about the system's recent IPL, specifically the IPL date, IPL time, IPL device, and the IPL volseer. The SMF ID of the current system is also being requested. This obtained OPSINFO data is then being used within the OPSREX address WTO logic to create an informational message in the ops log and syslog that can be easily filtered upon when needed. Generating alert messages or MLWTO banners is common logic performed within many automated applications. More often than not, you will want to direct these alert messages to the system's master console in which the automation is executing. Rather than hardcode the name of the system master console in the address WTO instruction to direct the message to that console, you can utilize the OPSINFO local master cons name function to dynamically obtain this console name. You can then use the return value of this function within the address WTO statement to dynamically direct the message to the local master console. Additionally, this type of logic is especially effective if the automation is running across many different systems, all of which have unique master console names. Familiarize yourself with the many available OPSINFO functions by executing a test OPSREX program in your TSO foreground. To do this, create a member in your OPSMVS user rex library, similar to this sample that invokes any OPSINFO function. Utilize the rex say instruction to simply dump out the returned OPSINFO function data. Quickly execute this code as an OPSREX program by entering and typing !OI on the command line to invoke the OPSREX edit macro. Various sample OPSMVS AOF rules and OPSREX programs can be viewed for more OPSINFO coding examples, as well as provide you with a syntax template that can be copied as you create your OPSMVS automation, and if the logic warrants, utilizing this function. Locate your installation's CCLX rules and CCLX sample OPSMVS datasets to access these members. Thank you for viewing this video. For more detailed information about this product, click the information bubble in the top right corner to load the product page. From there, you can go to product documentation, visit the CA communities, see the learning path, and much more.